hotel without breaking a sweat. Because we now instantly search over 200 booking sites to find you the lowest price.
Alright. We're going to show you how easy this is at this point. All the rest of the stuff kind of points to this, but here's our rules. Alright. So we got a recursive and explicit. And all an explicit is simply this. It is a start and a rule for a term. A start and a rule. If you start on the first term, all you have to do is back it up one term. That's all you do. If I start on the second term, I back it up two terms. And if we're talking about domain, if you start at 0, your domain is bigger than 0. If you start at 1, your domain is bigger than 1. All right. For recursive, it's the same thing, except your start comes right here, and then your rule is applied to the previous term to get the term you're looking at. And again, if you're starting on the 0th term, you only apply, well, there's your 0 and there's 1 on up. If you start on the first term, there's your 1 and there's 2 on up for your domain. So look, here we come. I'm going to show you how easy this is. It can get really easy here. All right. So I'm going to write explicit. I'll come over here and write recursive. You see this guy starts on 0. So literally all I'm going to do is I'm going to say, hey, function of n is equal to my start of 2, right, plus my rule. Well, let's find out what the rule is. It looks like, and we'll call that a difference. To get our difference, we take any term, we subtract the difference, previous term, our difference is 3. And you can see that, right? 2 plus 3 plus 3 plus 3. So we're going to say we're going to add our difference every term. And honestly, that's really it. And we'll say for, let's see, n looks to be between 0 and 5. Those are the only terms that we see up here, 0 to 5. Alright, well, let's do our recursive. I'll move it over here. So for recursive, you give your start, f of 0 equals 2. That's our starting spot. And then it says define any other term. We take our term before that, f of n minus 1, and we add our rule, 3. Right? I'll show you this actually. Let's say, well, let's finish this up first. We'll say for n is greater than or equal. We already got 0, so I only need 1 to 5 for this rule. So, just really quick. Look, if I wanted to use this to find the first term, I would plug it in. Here I go. I would say f of 1 minus 1 plus 3. That would give me f of 0 plus 3. Well, the 0th term we have is right here. It's 2. And 2 plus 3 is my first term. Just to show you how that works, how that backs you up one step. We can see that this is actually right there. It's 5. So let's keep going. Ready? Let's do another one. Or 2. All right. So notice this one starts on the first term. That's not going to change a whole lot. Let's go ahead and write explicit. And come over here and write recursive. I'll give myself a little more space this time. Here we go. F of n equals, what's our rule? Our rule looks to be minus 4. Do you agree? So we got our start, which is 29, minus 4 every term. But since we started on this one, we want to say n minus 1. That way when I plug in 1, I haven't really moved, right? That leaves me at 29. And then we'll say 4 n is looks like from 1 to 6, right? 1 to 6. All right, recursive. F of 1 equals 29. That's our start. And f of n equals my previous term minus 4. 4. Well, look, this asks me the terms. Instead of saying 1, I'm not going to use that. 2 to 6. Come here. You ready? F of n equals Well, my start, -7. Looks like it's +5 every time. And every term, I go up 5. Let's do recursive. F of 0, my starting spot, equals my previous term, +5, right there. Alright. 4, what do we got here? We've got n. Look, we got our 0 here, so I'm not going to include that. 1, 2, in this case, 5. Here we go. X. Implicit. Recursive over here. So here we go one more time. So let's just walk through this. So again, I need my starting spot, which is 5, and I need my rule. And it looks like every single one of these subtracts 6. So when we do it, f of n, right, this is the explicit terms, just like a linear equation. Here's my start, which is 11. Please note, though, that's my first term. So when I apply my rule, which is 6, I have to say n minus 1. 4, n looks to be between, I can actually plug in 1 and 6. Let's come over here to recursive. Alright, so again we say our start. In this one, my start is f of 1. I started on 1 for 11. And then to find my next term, to find f of n, I have to know the term before that, right? n minus 1, and then apply my rule. It looks like my rule is -6. And then we say 4, n is between, well, I've already got 1 up here. I don't have to use it again. 2 and 6. All right, I'm going to end with this page, and we're going to move on. The next page right here is going to have us do the same thing, except we're going to take a recursive and apply it.